pentane, right?
Yes, sir.
Normal pentane means there is no branching, all the carbon are one after another. There is no side branching coming out.
Yes.
In normal pentane, suppose if we take chlorine and sunlight, so how many different monochloro derivatives you will get? Monochloro means you are putting one chlorine.
Yes, sir.
Okay, so the pentane, what is the formula for pentane? C5H12. Okay, because alkanes have general formula of CnH2n plus 2, where n is the number of carbon atom.
Yes.
So if we do the chlorination, Imad, we will get, we will remove one hydrogen, okay,
Yes, sir.
and we will put one chlorine. So how many different structures are possible? That's the question is asking.
Okay.
So for that we need to look at the structure, okay? And we need to know how many different carbon atoms are there.
Okay.
Suppose there are 5 carbon atoms.
Okay.
Okay. Suppose in my both the hands I have 10 fingers in my hand.
Okay.
But how many different fingers I am having? Different types of fingers. There are 10 fingers in both of my hands. But how many different type of fingers are there? Similarly, you should also think in the same way in this question. Okay.
Okay.
Just a second. So though there are 10 carbon atoms, though there are 5 carbon atoms, but how many different carbon atoms are there? So this carbon are same. Yeah.
Yeah. CH2 CH2 same.
Yeah, CS, yeah, and this one are also same because these are at the second position from either right hand side or left hand side.
Yes.
Okay.
Yes.
And there is one carbon in the middle.
Yes.
This one, middle carbon atom.
Yes.
Okay. So though there are 5 carbon atom, but all 5 are not different. Only we have 3 different types of carbon atom.
Yes.
So we are going to get 3 different monochloro derivatives. Okay.
Yes.
And I can write their structures. What is the IUPAC name for this one?
5-chloro.
Yeah, 1-chloro.
1-chloro.
And 5 means pentane.
Pentane. 1-chloro pentene. Pentene.
If you need to check the carbon-carbon bond, and if there is a double bond, you will put in. If there is a triple bond, you put ine. But if all bonds are single, you will put in.
Yeah. Okay.
Okay.
Yes. Yes.
And then this one. And this one. What's the IUPAC name of this one?
1 chloro.
You need to count from end to end. Okay.
1, 2, 3, 4, 5.
Yeah. Now tell me.
Okay. So, 5 chloro,
Hmm.
5 chloro.
No,
And
number you need to tell me the position where the chlorine is attached. Okay.
okay. So 2.
Yeah. Good. So it is 2 chloro
2 chloro.
pentane, right? Same.
Yes.
Okay. And what about this one?
Same. So 3 chloropentane.
Yeah, 3 chloropentane. This is primary. This is secondary. And this is tertiary. Sorry, this is also secondary, not tertiary. Primary and secondary. Primary carbon is a carbon atom which is connected only to one carbon. Secondary carbon has 2 carbon on 2 of its sides. And tertiary carbon is the carbon which is connected to 3 carbon atom. So we have got only 1 degree primary and secondary halides, secondary chloroalkanes, not tertiary. Okay.
Yes.
So suppose if someone say, will 4 chloropentane form or not? What about 4 chloropentane? We have not written here.
Okay.
Someone may ask us that we have taken 1, 2, 3. Why we have not taken 4 chloropentane? There are 5 carbon atoms.
Yes.
So we should we should have 4 chloropentane also and 5 chloropentane also. But we have not taken that.
So I think because only we had learned about the first degree, second degree, right? Because of that, or
Because the fourth and the second carbon are same.
same. Okay.
And suppose if someone says, okay, this is the 4 chloropentane. What's wrong with it? Why it is not correct? Yeah.
Because second and fourth are not same; they are different.
Yeah. Actually, you need to do the numbering.
Okay.
You need to do the numbering from the side. Okay. Which give lower number. Okay. Suppose which is giving lower number to the carbon atom bearing the halogen. Okay. So we are showing 4 chloro, but this numbering is incorrect. Okay. This is just like how we eat food. Okay. Like this, not like this. We don't bring it in this way. Okay. That is a longer way.
Yeah.
Same way, while doing the numbering, you should start the numbering from the end, which gives the lower number. Okay. So the numbering is incorrect. So that's why the 4 chloropentane is not the valid name. Okay.
Okay.
So you need to do the numbering from this side because Cl is nearer to this end, left end. Okay. Right. So 2 chloro.
Sorry, sir. wanted to ask.
Yeah, tell me.
So, but how do we know that the numbering is incorrect? Because normally with this example, which you just showed, 2-chloropentane, the above example, we marked it from right to left, right? But
No,
from
you need to check from where it is nearest.
okay,
From this end it is nearest, or from this end it is nearest. In
okay,
this one, it was nearest, it was the Cl was nearer to the right end.
okay,
Okay. So you
okay,
will start numbering from right to left.
okay,
In this case, the Cl is nearer from the left end, so you will do the numbering from left to right.
okay,
So it is just same as that of 2-chloropentane.
okay.
Okay, so there are a lot of examples given to you. Okay, you can just try from your NCRT also, like this one. Okay, this 10.4.
Okay, 10.4.
Okay, in text questions,
Okay.
right?
Yes, sir.
Yeah, and you can try to name them. That will be sufficient. Okay, and the next thing is, how can we prepare? So this is alkanes. So alkanes, you can prepare alkyl halides by doing halogenation in the presence of light, sunlight, UV light. Okay.
Yes.
Why do light? Light actually helps to break the chlorine bond.
Okay.
Okay.
Yes.
Because if you mix them, the reaction will not start. You need to heat, or you need to put some UV light that will break the bond, and the reaction will start. Okay.
Hmm.
And what about this one? Is this a pentane?
No.
Yeah, there are 5 carbon atoms, and the common name is neopentane.
No penalty.
What's the IUPAC name of neopentane?
Uh,
You can start the numbering from one end to another end,
okay. 1, 2, 3.
and it is same from both the sides because the 2 methyl group are in the middle.
Okay. So,
Okay.
yeah.
So this is the main chain.
Okay.
This is known as parent chain.
Parent.
It has 3 carbon atom. So propane.
Okay.
Okay, propane, and on the second carbon you have 2 methyl groups.
2, 2, 2, 5.
Okay,
Okay.
so this is the IUPAC name. You select the longest chain, you name it, you number it, and whatever the groups are present, you put the numbers, and you put the numerical prefixes di, tri to tell how many such groups are present. Right?
Yes.
So suppose if you do the bromination of this, you need to take bromine, you need to take sunlight.
Yes.
How many different bromo derivatives you are going to get?
CH3, CH3, C, one, sir?
Yeah, only one. Correct. Because, okay, this is this, either this one, or this one, all four are same. There is no difference
No
because
difference.
they are connected only to one carbonate. That is why.
Okay.
So you can put anywhere. It may appear that they are different, that some may say that, okay, the Br is at the top carbon, or someone may say that it is at the bottom carbon. Okay. But actually they are same. This one. Or if you put the Br here or here or here, all four carbon are same. They are not different.
Okay.
So what's the IUPAC name of the product?
Uh, one, two, propane, 2-dimethyl.
Yeah, 2,2-dimethyl. That is correct.
Yes. Then,
You need to add one more thing.
oh,
And one more name you need to write.
bromine.
Yeah. You need to do the numbering from this. Okay.
Okay.
Because this chain has bromine also. You select the chain which is having the maximum number of groups attached to it. The longest chain having the maximum number of groups. Okay. So this is one bromo. One bromo 2,2-dimethyl propane. Is it clear? The common name is neopentyl bromide.
Okay.
The next thing is, so you can try these questions, very easy, you can do it. Okay. Chlorination and bromination are carried out directly.
Okay.
By reacting the alkanes with chlorine or bromine
Yeah.
in the presence of sunlight. Okay.
Yes, sir.
This is for chlorination and bromination.
Okay.
But why can't we prepare fluoroalkane and iodoalkane? Because we have four halogens. Okay, fluorine, chlorine, bromine, and iodine.
Okay.
Only the middle two can be attached by reacting the alkane with chlorine or bromine in the presence of sunlight.
Yeah.
Why can't we do fluorination or iodination directly?
Because of four halogens and sunlight affecting us.
Yeah, somewhat there is some problem. Yeah, fluorination and iodination. So they are not carried out directly by putting F2 and I2 in sunlight along with alkanes.
Yeah.
So reason is fluorination involves a lot of heat.
Yeah.
And you can't control it. Means once it starts, you can't control it. It will go out of control.
Oh.
And what happens is it even breaks the carbon-carbon bond, and there are more, not only 1, 2, 3, 4. The total, all the hydrogens break.
Oh.
So such type of reactions we don't do, where you
Oh.
can't control the reaction, where you can't predict what is going to form, and if the reaction is happening in uncontrolled way, they are not done.
Yes, sir.
On the other hand, iodination has some other problem.
Okay.
Because iodine is very less reactive.
So what is the iodination is given?
Very less reactive.
Okay. Very less. Yeah.
So suppose if you take methane and if you put iodine and sunlight,
Okay.
and you expect that CH3I and HI will form. But what happens here is that very small amount is formed.
Okay.
Very less amount is formed. And most of it remain unreacted.
Oh.
Okay. It is because iodine is very less reactive. Okay.
Oh.
So you can't prepare iodobenzene or iodoalkane and fluoroalkane directly.
Okay.
You use some other method. Okay, what you do, you take chloroalkane or bromoalkane, which you can prepare directly, and you heat it with sodium iodide.
Okay.
This is known as halogenation. So iodobenzene you can't have directly. You prepare chloro or bromobenzene,
Okay.
you mix it with the NaI and you heat it. So I minus will come and it will replace the chlorine or bromine.
Oh. Oh. So, but
So
sir,
this
how
is
heat is involved in this reaction?
how.
How heat is involved? Is heat involved in this reaction, or this
No,
chlorine?
actually, yeah, it's little bit heat you can give the one, but the most important thing is acetone, the solvent.
Okay. Okay.
Because you need to take something in which the sodium iodide can dissolve because it need to react.
Hmm.
Okay.
Okay.
And NaCl or NaBr, the Br which comes out, and that they are less reactive, they are less soluble, so they get precipitated.
Okay.
So the reaction gives that complete iodide. On its own, it was not forming.
Okay.
So now in the fluoride, if you want to make fluoride, you can heat it with AgF or Ag2F2. AgF is best because suppose if you have chloro or bromobenzene, the silver get precipitated with bromine, the bromine is removed,
Yeah.
and you have fluoride, right?
Yes, sir.
Okay. So in we covered some more little bit, for example, preparation of. Yeah, Anushka, good evening. Can you hear my voice?
Yes, sir. Good evening.
So just I was discussing something about from the last class from Iman. Yeah, Arpit, good evening. Can you hear my voice?
Good evening, sir.
Yeah, good evening. So apart from that, we covered till now what I covered. That's what I was discussing. We covered the preparation of alkyl halide from alcohols. Okay, this is your NCERT book, so all of you must be familiar with it, right? So this we did. Okay, and we were discussing about the preparation of aromatic halides. What are aromatic halides? Yeah. Yeah, repeat, tell me. Aromatic halides, just quickly.
So actually, I'm not like much clear with this chapter because we have just started in our previous batch. And sir, it's like far away, so I can't get to the topics right now.
No problem, no problem. Imad has also just attended one class, and with Anushka, we had few classes. Okay. So, Anushka, what are aromatic halides? Just quickly, can you tell me?
Sir, they are close chains like haloarenes.
Yeah. Or haloarenes. Yeah, correct. But is there any something special about the chain? The chain, yeah, it is actually, the chain also has consecutive double bonds in it. Double bond, single bond, double bond, right?
Yes.
So this is actually an aromatic group, and the most common aromatic group. What its name is? Can any one of you tell me?
So benzene.
Yeah, it is the benzene. So this is not benzene. Okay. You need to put double bond, alternate double bond, then it will become the benzene. Okay.
Okay.
So this is benzene, its formula is C6H6, and this is the most common aromatic ring. Most common aromatic ring, very common, right?
Yes.
So there are other aromatic compound also. For example, we have naphthalene, which has two joined benzene rings, which we use naphthalene balls at many places. Okay. So this is, all these are aromatic compound. Naphthalene, you must have observed that it has a aroma. That's so these are very common aromatic compound, but the benzene is the most common.
Okay.
So now the question is, Arpit, how can we prepare? Suppose if we have halide connected to it, Anushka, how can we, if we have halide connected to it, that is called aromatic halide, right?
Yes, sir.
So how do I do this reaction? How do I carry out this reaction? Suppose if I want to prepare chlorobenzene from benzene, how will I carry out this reaction? First of all, I need to take benzene and chlorobenzene because I need to put Cl, right?
Yes.
Yeah. So how do I put, how do I connect Cl here? Yeah, Arpit, any idea?
Hmm.
Anushka, what do I need to take here? Should I take
So,
sunlight? Hmm.
yes, sir, we can take sunlight.
No. Sunlight actually we used in alkanes, normal aliphatic groups. Okay. Sunlight is actually we used it in normal aliphatic groups. Normal like methane, ethane, okay. And suppose if you take sunlight, what will happen? All the bonds of the benzene will break and the reaction will not be in the way in which we want. Okay, suppose if you take sunlight, let me write here what happens. You get this, okay, and this is what, this is gammaxine, okay. So this is not what we want now. We want only one Cl to get connected. So what do we need in this case? Arpit, can you hear my voice?
Yes.
So because sunlight will give energy and all the bonds will break here, and in the benzene everywhere you have Cl. So this is benzene hexachloride, or it is also known as gammaxine. It is used as an insecticide.
Sir, can you repeat that again? Yes.
Yeah, benzene hexachloride, right?
Yes, sir. Thank you.
Or its commercial name is lead. But suppose if you want to prepare chlorobenzene, then how do I need to achieve this? Benzene to chlorobenzene. Yeah, Aishwarya. How can I get chlorobenzene from benzene? Can you hear my voice? So which type of reaction is this? First of all, tell me. Is it an addition reaction? Is it an elimination reaction? Or is it a substitution reaction?
Sir, I think it's an addition. Sir.
Okay, Aishwarya. So addition actually what happens? So if there is addition or reaction happening, the double bond get reacted. It is, so this was addition. The double bond, you will break the double bond and you will attach two groups on the double bond. That is addition reaction. Okay, so this is not addition reaction. Actually, you need to look more closely. Anushka, any idea what type of reaction, Aishwarya?
So is it substitution reaction?
Yeah, it is substitution reaction because H is displaced by Cl. So this H is H plus because Cl is minus. So H plus is removed and Cl plus takes its place. Okay, so this is a substitution reaction. Addition reaction, two things go and add to a double bond and the double bond is completely removed. Right? So this is a substitution reaction. And because, so who is substituting whom? Cl plus is replacing, substitution means replacement, that all of us know. H plus from the benzene. Okay, this is substitution reaction. Okay, right? So
Yes.
Cl plus is replacing H plus. So, but how do we need to create this Cl plus? Sunlight, if you take, that is for alkanes. Remember, not for benzene. You need to generate Cl plus so that it can come and join to the benzene ring and H plus will get removed. So how do you generate that Cl plus? Cl plus is generated by taking Lewis acid catalyst. Okay. So how this Lewis acid catalyst help? And you need to take dark. You don't have to take sunlight because if sunlight you take, addition will happen and all the double bonds will break and you will have Cl connected at all the positions. Is it clear, Aishwarya, Anushka, Arpit,
Yes, sir. Clear.
Imad?
Yes.
So suppose I will tell you how it is, what's the difference. Okay, I take a compound
Okay.
which has a aromatic ring, benzene ring, and there is a alkyl group also, a small alkyl group outside the benzene. This is toluene, methyl benzene. Okay, common name is toluene. And suppose if someone tells me I do Cl2H nu, where do I need to put this Cl? Where do I put this Cl?
So can you repeat the question again?
Yeah, where this Cl will get attached? In the presence of light,
Ah,
in the presence of UV light, where the Cl will get attached? It will get attached to the benzene more easily or the alkyl group?
alkyl.
Yeah, on the alkyl group. Remember one thing. Okay, there we attach it to benzene ring because we were not having any alkyl group. Okay, but if we were having any alkyl group, you will do the substitution at alkyl group. In the presence of light, you can write the substitution reaction will occur at the alkyl group. Arpit, is it clear?
Yes, sir.
So photohalogenation means in the presence of light. Photohalogenation means halogen in the presence of light will occur at, where it will occur, Anushka?
Sir, orthopara.
No, orthopara is actually the benzene. Photohalogenation reaction will occur at alkyl side chain or alkyl group. So which is the alkyl group?
Yes.
Yeah, this is the alkyl and this is the, which group is this, Aishwarya? Yeah, this is the aromatic group, right?
Yes.
Aromatic means benzene. And the side chain of normal side chain, methyl, ethyl, okay, 1 or 2, that is the alkyl group. Okay. So photohalogenation reaction will occur at the alkyl group. Okay, in the presence of light. So Anushka, what I will make here? Tell me quickly. Orthopara, or do I need to put Cl in this at CS3?
Yes, sir, it will be a CH3 only.
Yeah, it is. So this is known as photohalogenation of alkyl groups or alkanes. But if you need to put the Cl on the benzene, you must take a Lewis acid. Okay, Lewis acid catalyst you should take. So Lewis acid catalyst, these are metal chlorides. Okay, suppose if I take chlorine and if I take Fe or FeCl3, it is one and the same thing, because iron will get converted to FeCl3 in the presence of chlorine, and that is the catalyst, or AlCl3. These are Lewis acid catalyst. So what these Lewis acid catalysts do? This is not the halogenation of alkyl group. This is the halogenation of the benzene ring, right?
Yes, sir.
Because you have taken Lewis acid. Okay. So what I need to do? I will connect the Cl on this benzene. But where do I connect this? Aishwarya, how you are going to decide? Where do I put the Cl? Tell me. First of all, I'm not going to connect it to the CS3. That would have happened in the presence of light. Okay. I will connect the Cl to the not to the methyl, but to the benzene. Okay. Right. So, but where, because I have a methyl group, where do I put this Cl? Now, Arpit, any idea?
On the benzene ring.
On the benzene ring, but benzene ring has already one methyl. So with respect to that methyl, where? So these positions are known as ortho. These positions are known as, just if there is already one group and the positions adjacent to that group are known as ortho positions. Okay, these are positions known as meta, and this position is known as para. So I chose all the three options. Okay. So to draw, but all of them will not react. So what
Sir?
should be the answer? Yeah,
It will be on ortho and meta positions, right?
ortho and meta, ortho and para, para and meta. Yeah, you are
Ortho and
correct.
meta.
Yeah, you are correct. Any idea? Rian, can you hear my voice? Aishwarya, Rian, Arpit, Imad.
Yes, sir.
Sir, but how did we figure out this?
Yeah, Imad.
I think you just asked if you can hear your voice. Answer you.
Hmm. Where is the most where you can put. Okay, different positions are there with respect to, because one CH3 is already there, ortho, meta, para. Where Rayan, Aishwarya,
Yes,
could you
sir.
help? Yeah, could you help me? Where should I put the Cl with respect to methyl? Anushka has already given the answer, and half of the answer is correct. Another half need to be corrected. Yeah. So, guys, remember one thing, very basic thing. This is electron donating group. Electron donating group are orthopara directing group. Just remember one thing, or if you need to get into the reason of it, the reason can be bit long, it can be complicated. Actually, what happens here is, so this is a more easy way to remember. Okay, this one. You can get your answer very quickly. But if you need more deeper understanding, actually what happens is the CH electron density gets into the benzene ring. Okay, and it makes the ortho and para positions more electron rich. This is the more detail, but you don't have to do this, because if you would have done, if you start doing this, you will not be able to write your actual answer, because this is a lengthy process. Just I'm giving you for your satisfaction, for your explanation. Okay, so actually, or but this thing you can remember, and this will help you a lot. All the electron donating groups are orthopara directing. And why they are orthopara directing? Because they give electron into the ring, and the ring electron, actually because of that resonance, they come at ortho position, para position, and another ortho position. So those positions are the positions which become more electron rich. And in this case, you are putting H plus, Rayan, and removing H plus and putting Cl plus. Okay. So in the benzene ring, where the Cl is going to attach itself, okay, the Cl is going to attach itself and ortho and para position. So this is going to be the answer. I will write it once again. Okay, the major product is going to be ortho para. Is it clear?
Yes, sir.
This is going to be the answer. And how you are going to remember it? Arpit and Rayan, tell me quickly. Yeah, Anushka.
So, electron donating groups are also para directed.
Yeah, just write it as a thumb rule. It will help you a lot. Electron donating groups, or the group which have a unpaired electron, lone pair, they are orthopara directing. Okay, right? You need to take what? FeCl3. In dark, you need to carry out, because suppose if you would have taken light, then the Cl will get attached to alkyl group.
Alkyl
Okay?
group.
Yeah, that is the photohalogenation. Okay, so you need to take, if you want to connect the group to benzene, you need to take it in the form of plus. Okay, and depending upon the group which is already present, the new group which you want to attach can come at ortho position, para position, or meta position with respect to the group which is already there. And that depends upon the group which is already present. Electron donating groups are ortho para directing. This you can write, and this will help you to do the reaction very quickly without taking much time. Just write, okay, this one. Electron donating groups are ortho para directing. And the groups having lone pairs are also ortho para directing. You can write it as a thumb rule. Electron donating groups and the groups having, actually the groups which are having lone pair, that unshared pair of electron, they are also electron donating because the lone pair actually gets into the ring. Okay. Imad,
Yes, sir.
I hope you are getting it.
Yes, understand.
Yeah. So suppose if chlorobenzene is there, okay, and if I need to put one more chlorine on the benzene ring, I need to take Cl2, I need to react it with one more time, and I will not use sunlight because for reaction with benzene you don't use sunlight, you use Lewis acid, FeCl3, or sometimes you use AlCl3 also. That is also very good Lewis acid. Okay. So the chlorine has lone pair. So where do I put the new chlorine atom from which I am reacting over here? The second chlorine with respect to the first. Yarian, should I put it at the ortho or should I put it at the meta? Or Arpit, should I put it at the para position? Yeah, you need to have this thing in your mind and that will help you to find the answer. Electron donating groups and the groups containing lone pair, direct lone pair, okay, to connect, have on them, makes them ortho para directing. Means they direct the new group to ortho and para positions. Is it clear, Aishwarya? So Anushka, what should I write here?
So it will be attached to the orthopara positions.
Yeah. So this is, yeah, 1,2-dichlorobenzene. This is the Iupac name. And you can write the benzene as by putting a circle also or by putting double, single, double bond. And Arpit, this is 1,4 because you need to do the numbering 1, 2, 3, 4, 5, and 6. 1,4-dichlorobenzene. So ortho, this is ortho-dichloro. This is the ortho and this is the para. Why I have not made meta? Okay, because this is an electron donating group. Examples of ortho para directing groups you can write. Ortho para directing group are OH group. All the groups which have lone pair. NH2 group. Okay. OCH3 group. Right. These are all ortho para directing. Right. They are all ortho para directing. Or suppose if we have not only this one, NH, there can be some other groups also which we will see in the subsequent chapters. But you need to know the trick. Okay. You need to know the trick. And the lone pair is there. All the lone pair containing groups are ortho para directing. All the lone pair containing groups are ortho para directing groups for electrophilic aromatic substitution reaction. That you need to remember. Okay, all the lone pair containing groups or electron donating groups like methyl, ethyl, isopropyl is this one. Or tertiary butyl. They are all ortho para directing groups. Or the halogens, F, because they have lone pair on them. Cl, Br, Ni. You can note it down. This will be useful for you guys in all the chapters. Okay. All the chapters, these are ortho para directing groups.
Okay.
Okay. Meta directing groups are electron withdrawing groups. So electron withdrawing or the electron pulling groups are meta directing. And how we will make out that they are electron pulling? What feature we should look at in them?
Oh,
NO2 group. We write it as NO2. But in detail, it will be like this. Okay, this is the actual structure of NO2. And you can see that this NO2 group is electron pulling group because it is having plus charge. So groups having positive charge or groups having double bond on them, double bond O on them are meta directing. There are other groups also which are meta directing, not only the nitro group. For example, aldehyde group, carboxylic acid group, all the carboxylic acid derivatives, they are all meta directing, or the groups which are having a positive charge on them, like NCH3, all these groups are meta, or sulfonic acid. Look here, they all have same characteristics. Or C triple bond N. they have double bond, and at the other end of the double bond there is one non-metal atom sitting like oxygen or nitrogen, and that will pull the electron, and that's why they will pull the electron from the benzene, or they have positive charge, or they have some very highly electron withdrawing group like CCl3. All these groups are meta directing. Okay.
Yes, sir.
So it will be useful for you guys in all the chapters. Okay. And let's have some discussion related to them, and let's practice. It will take some time to practice. Don't worry about it. I will make you understand all the details of it. Suppose if I take nitrobenzene, and if I do the bromination, first of all, I will not take Br2 and light. This is not the way to do the halogenation of aromatic rings. I need to take Br2 and Lewis acid.
FeCl3 in presence
Yeah,
of
yeah,
charge.
yeah. FeBr3 also you can take. Okay. Or you can just simply write Br2Fe, because that Br2Fe will automatically react, and that will also give you, you need to take some more extra Br2. So actually FeCl3 also you can take, but actually because we are doing bromination, so it is better to have only Br everywhere. Okay. So FeBr3. Okay. Both are one and the same thing. And now my doubt is, so first of all, you don't have to take the sunlight. That is only for the alkyl group, methyl, ethyl, sp3 carbon. If you need to put the halogen on the double bond, on the benzene ring, okay, so you need to take some Lewis acid catalyst. This is a catalyst, metal bromide or metal chloride. But now my question is, where do I, with respect to this NO2, where should I put this halogen? Should I put it at the bromine at the ortho position? Should I put the bromine at the meta position? Or should I put the bromine at the para position? Yeah, Arpit and Ryan, tell me quickly.
So meta position.
Yeah, meta position. This is the major product. Why meta?
So because it's strongly electron pulling group.
Yeah, electron withdrawing group. Suppose if you want to get into the detail, this is just the thing, this is just a shortcut way which will help you to quickly answer the question. This is the list of the orthopara directing group and the meta directing group. This is orthopara and this one is meta directing groups. Okay. And suppose if you want to get into the detail, okay, this is going to be our product, that why it is so. So it is actually like this. Let me explain you a little bit. Actually, this is FeBr3. So it has only 3 bonds. Means it doesn't have 8 electrons. It is having only 6 electrons. And you guys know that the element which is having the compound which is having 6 electrons, they try to complete it by accepting 2 more electrons.
Yes, sir.
So what they will do, they will, right, so they will actually, this FeBr3 is a Lewis acid catalyst, so it will break Br minus. Why it will break Br minus, Anushka? So it will be happy if it is having 4 Br. Okay, its octet will get complete, right? Aishwarya?
Yes, sir.
So what is left if you remove Br minus from Br2? You were having Br2, Imad,
Yes, sir.
yeah, and you remove Br minus. You are left with what?
We are
Br plus. Okay.
yeah.
Yeah. So who helped us to break Br minus away from Br2? FeBr3.
Yes, we are.
Okay. So that's why it is helping us. So that's why it is known as catalyst. Because catalyst are substance which help the reaction to occur more easily. Okay. So this
Okay.
Br plus is generated. And this Br plus is an intermediate. So this Br plus need electron. Okay.
Yes.
So electron, from where it will get the electron? From the benzene ring, because benzene ring is a rich source of electron. But because this NO2 group is also pulling electron and it will have plus charge at ortho and para position because of this NO2. So this Br plus, the NO2 is also, NO2 also wants electron, because you can see that NO2 is having this plus charge. Okay. So NO2 also wants electron, and the Br which is coming to the benzene, that also wants electron. And because of the NO2 connected to the benzene, the ring has plus charge at ortho and para positions. So where should I put my Br? Where it will get connect, where it will be connected more
The
easily.
meta
Yeah,
position.
yeah,
Meta.
yeah. Because if it approaches Harpit, Animad, and Ryan, if it approaches the positive charge, it will be repelled away because same charges repel. Okay.
Yes, sir.
So where it will come and join itself
Meta
at the
position.
meta.
Meta position.
So that is the reason why it is meta-directing.
Okay.
Okay. That's why it is meta-directing. Okay. Let's do one question. Suppose if you would have taken toluene or methyl benzene,
Okay.
and if you reacted with Cl2 H nu excess, what you will get?
pH.
Sir, ortho para position.
This is, are we attempting to connect the Cl atoms on the benzene ring or on the side chain? Alkylation,
Sir, on the side.
On the side chain.
on the side chain. And because we have taken excess chlorine, so how many Cl do I need to put on the side chain? This is a side chain halogenation,
Yes.
okay, of the alkyl. How many Cl can I connect to the side chain?
Cl.
1, 2. Normally, if nothing is given, we connect only one Cl. But in this case, how many Cl do I need to connect on this methyl? Yeah.
1.
Suppose if I connect 1,
Yeah.
it become CH2Cl.
Yes.
Okay. But I have taken chlorine in excess, means more Cl atoms are left.
So 3 or
How many, Iman?
3, sir.
Yeah, they will. So one more hydrogen will be replaced by Cl. Right, Arpit? Ryan?
Yes, sir.
And now you are having more Cl2. One more hydrogen will be replaced by Cl. Okay. So that's how you will have CCl3. Okay,
Sir,
right? Yeah.
so how did we have 3 chlorine when there is only 2 present?
No, 2, but you have taken many moles of it. Excess you have taken.
Yes, sir.
Okay. So Cl2 1 mole, Cl2 second mole, Cl2 third mole. Okay. Or you can write it like this. Okay.
Okay.
So earlier, remember when we were doing the chlorination aromatic substitution of the benzene ring, methyl was orthopara directing. So the Cl atoms were connecting at the ortho and para positions. Just now we had seen it. Okay. So first I did photohalogenation. So I got this as the answer. Okay. And now if I try to do the aromatic chlorination by taking Cl2 and Fe Cl3, here I will not take light, I will write dark. In no light. There I will write light, sunlight or H nu. So now where the Cl is going to connect itself?
Sir,
On
it's
the
into the benzene.
on the benzene ring. But where with respect to the benzene?
Orthopara.
This is CCl3. The situation has changed entirely. Initially it was methyl. Now it is trichloromethyl.
So it will be on meta position.
Yeah, it is meta. These are actually strongly electron pulling group. So carbon will have positive charge. Okay. Chlorine are actually strongly electronegative groups. So it will have a positive charge. And because of the positive charge, the ring wants electron. So if there is a group which is electron withdrawing, then it is a meta directing group. So suppose if you do the Cl2, I will write here. So Cl2 FeCl3. So it is a meta directing group. And who suggested us that it is a meta directing group? How you got the idea, Anushka? Rian, Arpit,
Sir,
Emad.
because CCl3 is strongly
Yeah,
withdrawing group.
yeah, because with so many Cl atoms, the carbon will have strongly, it has become a strongly electron deficient. And that makes the ring electron deficient. Yeah, Emad.
Nothing, for just writing that down.
Pardon?
I'm just writing that down.
Yeah. You can write and tell me if you have any doubt, any problem. Okay, do stop me.
Sir,
Hmm.
sir, could you scroll up and show the meta directing group as well?
Yeah. Yeah. Just keep it front of your study table. You will never feel any trouble in doing the questions. Okay, these are meta directing groups. All the electron withdrawing group. And in case if you forget, what's the trick? The group groups which have directly double bond oxygen, double bond nitrogen connected on them. Groups which are having positive charge. Groups which are connected to electronegative atoms are electron pulling groups, and they are meta-directing. An ortho-para-directing group, alkyl groups, electron donating groups, groups which have lone pair on them are orthopara. Clear?
Yes, sir.
Yes, sir.
So I hope this is clear to all of you, right?
Yes, sir. Clear.
Okay. So Imad, have you copied?
Yes, sir.
Ryan, Arpit, any doubts? Okay. We are having the same thing in your NCRT also, but actually they have not given explanation. Just a second. In NCRT, where we are having it in the preparation of aryl halide. Yeah, this one. Okay. So this is electrophilic substitution reaction, because how you generated the electrophile? By taking Lewis acid catalyst. This is Fe dark but FeCl3 or FeBr3 dark. Lewis acid catalyst like iron 3 chloride. Ortho-para isomers can easily be separated. Okay, suppose if someone asks you, I need only ortho, you can do the distillation and you will get the ortho product. Okay. Right. So, but in NCRT, they are assuming that you have studied this in class 11, so they have not given any details. But it is there in detail in class 12. They are assuming that because you have studied in class 11, part 2, that's why they have not given any much details. Okay. So, but you need to cover it in detail. Okay. Other thing is, you can carry out chlorination directly of the benzene ring by taking Cl2 and FeCl3. You can do the bromination also in the same way. But you don't carry out chlorination and iodination of benzene directly. Why?
Because excess of heat for fluorine is exothermic because electrothermic fluorine.
Yeah, fluorine, if you start doing the reaction will happen, but it will happen so fast, it will happen so quickly that you will not be able to stop it. They are not prepared directly. The problem with fluorine is different, that it is uncontrollable. You can't stop the reaction, the heat, it gives a lot of heat, and the heat is so much that it breaks the benzene also. So what is the use of doing such reaction which actually breaks the substrate or the reactant which you took, that is broken into small molecules. What's the use of this reaction? You can't do it. Okay. And iodobenzene, Arpit and Rayan, Imad have different problem. If you take iodine is very relaxed. Okay, because it is a very large atom. It has very less reactivity. So the reaction doesn't get completed. Okay. So suppose if you take benzene, iodine, and there is one more problem, we don't have FeI3, Lewis acid. And even if you have, the reaction doesn't get completed. You can write benzene in both the ways. Look, I've used two different ways to write the benzene. So if you think that the benzene will react with I2 and form iodobenzene and HI, it is very small amount is going to form. Goal of the reaction, I will put two arrows and the backward arrow is very long and the forward arrow is very small. It is indicating that the reaction is almost in the backward direction. So whatever the reactant which you have taken, they are not reacting, they are unconsumed. You can see here also. Iodine is a reversible reaction in nature. Okay. So what's the way to do it? There are two ways to do it. Okay. So suppose if someone say no, do the iodination directly, you need to forcefully push the reaction in the forward direction. Okay. And how do you push a reversible reaction in forward direction? What's the way? Anushka, tell me.
Sir, we can do it in the presence of HNO3.
Yeah. Actually, what happens is, suppose you can react, you can consume one of the reactant, one of the product, and what happened, the reaction is not getting completed. So what you can do is, you can take something which can push the reaction in the forward direction and you can remove the products. As the product will decrease, the reactant will react more quickly to form the products. Okay. That you must have studied in, if you remember, in chemical equilibrium chapter in class 11, Lee-Chatterley principle, where
Yes.
right. So if the reaction is in reversible and it is not getting completed, Arpit and Ram, so you use some oxidizing agent. Oxidizing agent is HNO3, HiO3 you can take. So what these oxidizing agent will do, they will consume the HI and they will convert it to I2. So what is happening? The HI is getting consumed and I2 is forming. So more and more I2 is accumulating. So it will put pressure on the reaction to move in the forward direction. If you are accumulating the reactants and consuming the products. So that's how it is done. So iodination of benzene ring, actually it is not, mostly it is not prepared directly because what is the reason? Iodine is very less reactive and the reaction doesn't complete. On the other hand, fluorination is, fluorobenzenes are also not prepared directly by taking F2 and benzene because fluorination is highly exothermic and uncontrollable reaction. Such reactions, actually, I was having experience of some chemical industry. So such in chemical industry, not at your level, just an extra thing I'm sharing with you guys, that in the chemical industry, such reactions are known as runaway reactions. Runaway reactions means it is a kind of a joke, okay? You start the reaction and just run away from there, okay? Why you have to run away from there once you start the reaction? Because if you, that reaction will ultimately blow away, okay, like a bomb, okay? It is uncontrollable. So such reactions are, so fluorination is also one of such reaction where you can't control it, and if you can't control a reaction, what happens, okay, it gives a lot of heat and it blasts, okay? So such reactions are not carried out directly. Iodination is another thing, okay? So iodine, we found the treatment. What was the treatment? That if someone deliberately asks you to do the to prepare iodobenzene by taking iodine directly, so you will say, okay, we will do it in the presence of oxidizing agent. The role of the oxidizing agents is to consume the liberated HI and to convert it into I2, and that will help the reaction to move in the forward direction, right? So this is the way to do this reaction, okay? But there is indirect way also, okay? There is indirect way. Instead of attaching iodine directly or fluorine directly is not possible, or chlorine or bromine directly. So there is an indirect way of doing the electrophilic aromatic substitution on benzene ring. So preparation, so this is a next subtopic of this chapter only. But this subtopic, this method of preparation is not from this chapter. It is actually useful everywhere. Okay, this is a long process. So part of it I will do it in this, but it will be there in the phenol chapter. It will be there in the amines chapter. Okay, everywhere it will be useful. So aromatic halides we were preparing. So what's new? By a new method, alternate method, not directly. Anushka. So it is via diazonium salts. Okay. So diazonium salts are a special class of compound, and that can help you to prepare halides, aryl halides, aromatic halides, and even those aromatic halides which can't be prepared directly. But by this diazonium method, you can't only prepare aryl halides or aromatic halides, you can even prepare phenols, you can prepare benzonitride. Okay, so this chapter will be, this topic will be there in all the chapters. Okay, so let me tell you quickly. We will cover it in the subsequent chapter. So you have benzene. You take nitric acid and H2SO4, that is a mixture of two acids. H2SO4 removes the water from nitric acid and gives NO2 plus, and you have a nitrobenzene. This is also reaction, electrophilic aromatic substitution reaction, the same thing which we have seen over here, right? This was also electrophilic aromatic. There the electrophile was Br plus, here it is NO2 plus. We will study it in the amines chapter, okay? So this is nitrobenzene. This nitrobenzene, you do the reduction. Don't worry about it, because this will be useful in a mines chapter, the complete detail. As of now, I will tell you where you need to concentrate. So this is reduction. So O become H2, O2. Aniline. This is the preparation of diazonium. Now we are doing. So actually the preparation via diazonium, you require a diazonium compound. But diazonium compounds are not the compounds which are directly present in the lab. You need to prepare them from benzene. You need to prepare nitrobenzene. Nitrobenzene, you need to do the reduction. Aniline. Aniline, you again need to react it with NaO2 plus HCl, and you have this diazonium compound. So don't worry. Don't even think that it is too long or something, because it will be very, you all will be have this whole thing on your tips, okay, fingertips, very quickly, because it is there in all the chapters. So this compound is known as diazonium. But this is not readily available in the laboratory, just like your HCl, nitric acid, H2SO4. This is prepared. How it is prepared? You first take benzene, you do the nitration by taking mixture of two acids, you get nitrobenzene, you do the reduction, you get aniline. Aniline, you react it with NaO2 plus HCl. That is the preparation of diazonium from aniline. And you get this diazonium salt. Why it is called salt? Because you have a cationic part and you have an anionic part. Just like salts, NaCl, you have an A plus and Cl minus. Okay. So this is a diazonium salt. So for preparation of aryl halide, we need this diazonium salt, but we need to prepare the diazonium salt also. And this is the way. Now the diazonium salt, actually, why it is so, and you note the temperature. The temperature is 0 degree. It is kept cool so that it doesn't break easily. It has a tendency to break away very easily. Okay. Why it breaks away? Because this is nitrogen. And you know the nitrogen is very stable. It breaks away very easily and it can come out very easily as a nitrogen gas, which is very stable. And in our atmosphere, you know, we have 70% nitrogen, which is very stable. So it will break away and give nitrogen. So in order to stop breaking it, you take low temperature. Suppose if you want to put Cl, you can use CuCl plus HCl or Cu2Cl2, okay, and HCl and heat, okay. And because you are heating, so the N2 will come out and the Cl from CuCl or HCl will join itself to the benzene line, okay. So you will end up with a chlorobenzene, okay. Suppose if you take CuBr plus HBr, now you can heat, because now you need to break it and put your bromine. The Br will come and join because you are heating, N2 will go out and you have bromobenzene. Is it clear? Yeah, tell me.
Yes, sir. Clear.
Okay. So but diazonium is, you need to prepare it. So it is not a direct way. Sometimes in the question they will give you diazonium directly, or sometimes if it is not given, you need to prepare it from the scratch by taking benzene, doing its nitration, doing its reduction. So you get aniline, and from aniline you get the diazonium.
Okay.
This is the method. Okay. Yeah, Imad.
No, sir. Just can you just explain the second reaction? Just explain. Just explain.
Which one?
The diazonium salt.
Yeah, diazonium salt. Actually, this functional group is known as diazonium.
Okay.
Okay, and what it is, the N2 plus group connected to the benzene.
Okay.
So it has a tendency to pull this electron and come out as N2.
Okay.
So the electrons are pulled out of the benzene. Why N2 can come out so easily? N2 is a very stable molecule. We know our atmosphere has 70% nitrogen. So it can break away easily, leaving behind a positive charge, and we can take the advantage of this breaking of diazonium. We can put Cl minus or Br minus in this case, or F minus also. Okay, so if you take cuprous salt and HX, cuprous bromide and HBr, cuprous, this reaction through this preparation through diazonium is known as Sandmeyer reaction. It has a name also.
Okay.
Arpit, Ryan, is it clear?
Yes.
And this is very, very important. You need to know the name. So diazonium, if you react it with CuCl plus HCl, it is Sandmeyer. CuBr plus HBr, you will get Br attached, Anushka, and it is Sandmeyer. But if you take copper powder, again you will have Br connected. But the name is different, it is Gatterman. Gatterman reaction. If you have in the Gatterman, by Gatterman method, if you want to prepare chlorobenzene, you need to take only copper powder and HCl. Right?
Okay.
Heat. You need to heat it because then only the N2 will break away. Arpit, is it clear?
Yes.
So for the preparation of chloro and bromobenzene, it is just an added, it is actually a long way. So we are not very much interested by preparing chlorobenzene and bromobenzene by this method because it is just like eating, just like actually taking a long route. Okay, because directly if you can have chlorobenzene by reacting benzene with Cl2 FeCl3, why will someone convert the benzene to nitrobenzene, then to aniline, then to diazonium, and then to chlorobenzene by Sandmeyer method or Gatterman method? Okay, this is a long way, long process. Okay, but you need still, but sometimes the question comes, so still you need to know. Okay, that is very important. But the main advantage of this process is to prepare fluorobenzene and iodobenzene. Because chlorobenzenes were not, we are not able to prepare directly. Because if you take chlorine, you can't control the reaction, whole reaction mixture will blow away. Okay. So the main advantage is for chlorobenzene, for the preparation of fluoro and iodobenzene, right?
Yes.
Yes. So how do we need to prepare fluorobenzene? For Cl and Br, there are two methods. Sandmeyer and Gatterman. You need to look at the copper. If you have taken copper powder, that is Gatterman. If you have taken cuprous halide, cuprous chloride, cuprous bromide, then it is Sandmeyer. Okay, for preparation of F, there is another method. Okay, you need to heat it. I'm writing over here, or let me write it completely different. So you already have some diazonium salt. N2 plus, X minus, okay. And if you heat it with HBF4, just a second. It is sometimes written as HBF4 or it is also written as HF plus BF3. BF3 will get attached to F minus, so it will be HBF4. The name is, sometimes they will not give you formula, they will give you the name. So hydrofluoroboric acid, a hydrofluoroborate, right? Tetrafluoroborate. Okay. So if you heat it, the F minus will come and get attached. N2 will break away because it will come out as a gas. And you will have F minus attached to the position where N2 was connected. Right, Imad?
Yes, sir.
So you will have N2 and now VF3, they will all come out. So this is the main thing. But the reaction name, it is the preparation via diazonium. Okay, this is known as Chechman reaction. The complete name, Chechman, Bal Chechman. This is a way to prepare fluorobenzene, and that is via diazonium. This diazonium, it is given you directly, Arpit, Ryan, Anushka, well and good. And if it
Yes,
is
sir.
not given directly, Ryan, you need to prepare it from benzene. Benzene, nitration, nitrobenzene, reduction, aniline, NNO2 plus HCl, diazonium, and diazonium if you treat it with HBF4, okay, then you will get fluorobenzene. This is Chechman reaction, okay. So if someone asks you how will you convert benzene to fluorobenzene, what you will do? Tell me. Do the following conversion. How will you do it? Yeah, Imad, you need to start from the scratch. Arpit, Ryan, how will you do it? Suppose if they give you conversion to ask you to convert benzene to fluorobenzene, and you can't do it directly, Anushka. So how will you start? Yeah, tell me.
Yeah.
So benzene is there.
So benzene can be reacted with HNO3 or in presence of?
Yeah, it is reacted with HNO3 and H2SO4.
Okay.
And
And
that
we can reduce it. Then.
Yeah, we can convert it into nitrobenzene. Yeah.
Okay.
Okay. Nitrobenzene is reduced by taking 10 HCl. There are many ways to reduce. We will discuss it in a MEI chapter, or metal and acids are good reducing. Tin and iron. So that will remove the oxygen, Anushka,
Yes, sir.
and put hydrogen, NH2. Okay. Now we can convert it into NH2 can be converted into diazonium by taking NaNO2 plus HCl. You need to keep the temperature low so that you can protect the diazonium. Sometimes what they do, they write nitrous acid also, HNO2.
And then we have to react it with copper powder, no?
No, not copper. That was for chlorine and bromine.
Oh, sorry.
For chlorine, it was what? It was heating with HbF4, right?
Okay.
So that's the way. This is very important. So do remember it. Okay. So let me give you one conversion for
Sir,
CBSE.
could you just go up for a minute?
Yeah, definitely. But oh, I missed how to prepare iodobenzene. I told you diazonium, you can convert it into chlorobenzene by two methods. Sandmeer and Getterman. I told you to convert diazonium to bromobenzene by two methods, same two methods, Sandmeer and Getterman. The fluorobenzene can be prepared by heating diazonium with HbF4. Okay. And how to convert because we need to convert this diazonium to iodobenzene. So just write it. N2 plus, this is the diazonium salt, but this I have written here readily. You need to prepare it. Suppose if they give you need to prepare it from benzene. This is the whole process you will follow. Right, Anushka?
Yes, sir.
So diazonium you have taken, you heat it with Ki. So Ki, Imad, what? I minus
I
will come and join in place of N2.
okay.
Okay. So Arpit and Ryan, what we will have here? So we will have iodobenzene. Is it clear?
Yes, sir.
Iodobenzene, right? So, but this has no name. It is just a common name, preparation of iodobenzene by diazonium salt. Okay. So this is very, very important. Okay. So let's do one conversion. Very important question, very famous question. Part of it or as a whole can be asked in your CBSE examination. What you will get here? What is the structure of A? So then you take You need to tell me what are A, B, C, and so I'm telling you the complete reaction, part of it or complete can come. Okay. So very important, and this will, you will revise all the concepts. Now you need to know, you need to tell me what are A, B, C, and D, E and E. Yeah, Arpit, Ryan, what is A? What is A? Anushka, Iman,
Yes, sir.
what is A? Yeah, what is A?
Bromine.
This is nitration.
Nitration.
Okay, you can, or you can remember it in this way also. This is a trick. Nitric acid, you can write HNO3, OH and NO2. You can take H from the benzene, you can take NO2 from, you can take HNO3, and you can remove water and put NO2.
Okay. Nitration.
Okay, so this is nitrobenzene A. Ryan, is it clear?
Clear, sir.
Arpit? What is B? Now you do the this is A. Yeah. Bromination.
Yeah.
Yeah, what is B? What is B? Where I will put the Br with respect to NO2, Anushka?
Sir, in the meta position.
Yeah, meta position. Yeah, this is B. And what is C? So NO2 was electron withdrawing group. Just remember, this is actually meta directing group. So Br will come at the meta position. What is C?
Diazonium.
Yeah, SnHCl is the
Diazonium. Okay.
metal and acid.
Metal.
It is the reduction.
Reduction.
Okay. So what we are going to get here? NO2 will get reduced to what? NH2, aniline. So this is meta bromoaniline. Okay. Anushka, is it clear? C.
Yes, sir.
So what will be the structure of D? This is what?
Diazonium.
Yeah, this is diazonium. I actually need to put 0 to 5 degree. Yeah, this is NNO2 plus HCl. So diazonium is N2 plus Cl minus, right?
Yes, sir.
So this is diazonium salt, and the bromine was already there that you connected.
Yes.
at this step. And what will happen with E?
The determines reaction.
Yeah, this is Getterman reaction. So what will form? What is the final answer?
Fluorobenzene.
Yeah, it is meta dibromobenzene.
Okay.
Okay. So you have two bromine groups. So this was also replaced. So why we took such a long route, Anushka? Why we took such a long route? Actually, suppose if you do the direct bromination and if you do the bromination again, okay, the next bromine is going to attach itself because this is ortho-para directing. So the next bromine is going to attach itself to either ortho or para. Okay. You can't have it at meta.
Okay. But
Okay.
sir, why not on meta?
So meta, actually you can't have it at meta. So you prepared nitro, you put and you convert it into aniline because it was electron donating group. So suppose if you attach one bromine, if you attach second, it will be at ortho para only. Okay.
Yes, sir. Thank you.
Can't have it at meta. So
Okay.
how you created meta? You first put NO2, you did bromination. Okay, Br2 FeBr3. So that was meta nitrobromobenzene. Okay, then you converted this NO2 group to aniline, converted it to diazonium, and that diazonium is converted to bromine. So indirectly you had meta dibromobenzene. Okay, so this is a very important reaction. You need to practice it. Okay, don't worry, because this will come again and again. So don't worry about it. Right? So let me end today's class. I hope you understood. Anushka, any doubts?
No, sir, no doubts. Understood.
Ryan, any doubts?
No doubt, sir.
Yeah, actually, first time it will appear difficult. Okay, so don't worry. I will make you understand all the things, and you will be very fluent in this. Okay, Imad?
Yes, sir.
And yeah, you will be able to do it much quicker than with the speed which I am doing. Okay, so don't worry. Just stay relaxed and keep on studying it. Okay, so let me end today's class, and I will share the assignment. So do the assignment also, right?
Yes, sir.
Okay. Okay. Bye everyone. Good night. Take care.
Thank you, sir. Bye, sir.
Thank you, sir.
Okay.